Hi everyone. So this is going to be the last lesson in the chemistry section, lesson 5, acids and bases. And what this lesson is going to be most useful for you in terms of this course, the greatest usefulness to you, will be as the background needed for you to complete your final assignment for this unit. All right, learning goals. So what we're going to go over here is the properties of acids and bases. What are they sort of like? Learn what a neutralization reaction is, and can we write balanced equations for these types of reactions. So we're going to start off with a bit of a weird philosophical question. If I was to ask you, what is a chair, or can you give me a definition for a chair? And so this is like a famous question, but it's really hard to do this, right? You could say something like a seat with 4 legs. And that would work for a lot of chairs, but then there are chairs that don't have 4 legs. So maybe just something you sit on, except there are lots of things that you sit on that aren't chairs, and there might be some chairs in a museum that you're not supposed to sit on. So the point is you can give a definition that generally works, but one definition for a chair is probably not enough. And the same is true for acids and bases. So for the purposes of this class, we're going to define an acid as a substance that releases H+ ions into solution. And this is a definition of acids that is used. If you take grade 11 chemistry, you will see this definition again. But if you take grade 12 chemistry, what you'll see is that there are other definitions for acids as well, because many things that behave a lot like acids don't do this directly. And so just note that there are other definitions for acids and bases. And this is especially important, I think, to avoid confusion when we talk about bases, because often in grade 10 you're taught that bases release OH- into solution, which is true. That is a definition for a base. But then people see things like baking soda, sodium bicarbonate, NaHCO3, and that doesn't have OH in it, at least not OH- hydroxide. So there's a potential for confusion. How is that a base? It can't release OH- into solution. So just know that there's more to the definitions that we're going to get to in this course. But these are definitions that work for a lot of substances, and so we're going to use them. Okay, properties of an acid. So we said that what are these things? These are things that release H+ into solution. So what are these things like? Well, if you taste them, they taste sour. Their pH, if you measure their pH, it's below 7. So it's from 1 up to 7, but lower than 7. They react with metals to produce hydrogen gas. Some metals are more reactive than others, and some acids are more reactive than others, but generally speaking, that's what they will do. If you put litmus paper into them, the litmus paper will turn red. They conduct electricity, and that makes sense if they're releasing ions into solution. They're charged particles, so they can conduct electricity. And the chemical formula usually begins with H, so things like HCl, H2SO4, H2CO3. So these are all acids. Okay, and just to make sure that we're aware, some acids can be extremely dangerous. If you have a concentrated strong acid like hydrochloric acid, and you pour that on your hand, you'll get a nasty burn. But other acids are pretty mild and important for us, right? So things like citric acid, in its less concentrated form, and say things like oranges or lemons, can be, useful to us and even nutritious, or part of something that's nutritious. Okay, so that's acids. What are bases? So we said for the purposes of this class, substances that release OH- ions into solution. So this is the definition we're going to go with. And that definition does actually work for things like drain cleaner, which are often based on sodium hydroxide, NaOH. So you can see there's an OH in there to be released. So this stuff you definitely also wouldn't want to get on your hands. This will give you a nasty burn. So sort of strong and concentrated acids and bases are both very dangerous to our tissues and cells. Baking soda, of course, is much milder. It is a less concentrated, in its less concentrated form. It's also a weak base. It's a very weak base, actually, so even if you concentrate it, it's hard to make this really harmful. So yeah, we use this, as you might be aware, in baking, right? It can help things rise because of the way it can react. It releases carbon dioxide, creating bubbles. So we can use this to make bread rise, for example. So what are the properties of bases? Well, they taste kind of bitter. They feel slippery. The reason why they feel slippery is actually kind of interesting and weird. But it turns out that one of the reactions that bases can participate in is they can react with fatty acids and create soapy kind of material. In fact, you can create soap this way. So if you get a base on your hand and it feels slippery, it's because it's turning some of the fatty acids in your hand into soap. So I don't know if that's mildly disturbing or not, but yeah, that's what's going on. They turn litmus paper blue. They have a pH above 7, so between 7 and 14 is usually as high as we go. And again, because they release charged particles into solution, they can also conduct electricity. All right, so the last thing to cover here is neutralization reactions. So when an acid and a base come into contact with each other and react with each other, they form more neutral compounds, meaning they form compounds that aren't as acidic as the acid and are not as basic as the reactant, as the base. So if you imagine that the acid that you poured in was pH 1 and the base was pH 14, then your products are going to be at some pH between those two. So they're not going to be as acidic as pH 1. They're not going to be as basic as pH 14. And remember, the way the pH scale works is that neutral is 7. And if you go below 7, you get stronger and stronger acids. And if you go above 7, you get stronger and stronger bases, so to speak. I'm using the word strong a bit loosely there, but that's the general idea. So the lower the pH, the more acidic something is and the more H plus it's releasing. The higher pH, the more basic something is and the more OH minus it's releasing. Okay, so if they neutralize each other, they have reacted. So what do they actually form when they react together? They'll form something called a salt, which is really just an ionic compound. NaCl is a salt, but so is KBr, so is calcium chloride, CaCl2, for example. All the ionic compounds that we've dealt with before in this course, if they are created in this kind of reaction, we just call them a salt. Water is also formed, and as we said, water is not acidic or basic. It's pH 7. Depending on the situation, it can behave in one way or the other, but we generally say it's a neutral substance. And this type of reaction is actually really just a double displacement reaction. So if I show you this reaction, you should notice it's following the same patterns as the reactions that we've already covered. So let's take a look at one, for example. So a neutralization reaction is acid plus base to give salt plus water. So we have here, would this be an acid or a base, and how would you know? Well, remember we said that acids tend to start with H, so this starts with H. This is HBr, this is hydrobromic acid. And here we have a base, so this is just potassium hydroxide. And they are going to react to form potassium bromide, which is a salt, and as we said, water. So notice the double displacement that's going on here. So you've got a compound here, and you got a compound there. So the H is replacing the K. And the K is replacing the H. So let's look at the K replacing the H first, because I think that's easier to see. So if the K kicks out the H, then we have KBr. If the H kicks out the K, then we have HOH. Well, what's HOH? There are two H's and one O, so that's H2O. So this really is just a double displacement reaction. Okay, so that's generally all I have to say about acids and bases, just to give you some quick background. I'm not going to go into naming acids in this course. It is something that you should look at if you want to take grade 11 chemistry, but we have enough going on already, so I'm not going to burden you with that. And the rest of this topic is going to be project-based. So hopefully you have enough of an introduction to this topic to be able to go out, do your research, and complete your last assignment. Okay, so that's the end of lessons for today. Have a good one.